Hello guys, welcome back to Maison African Motives. Still working on mathematics and three revisions, that is on exponents and logarithms. Working from the question paper of November 2020, we've got question 2, where we are given the first part of our question, that is 2.1 in this case. All right, so we've got the first part of our question 2.1. Simplify the following without using a calculator. So take note here, without using a calculator. So that means whatever that you're going to have this part, we are not supposed to use a calculator. All right, so that was 3 marks for this part. Let us try to have our question here. So a given without a calculator. So what can we do in this case? We are multiplying logarithms. If we check from our laws, that is very, very difficult for us to multiply this part. So the easiest part that we could have done here was to change this to the same log in this case to fractions. The same logarithm that we have, we change these to fractions. All right, so how can we write a log as a fraction so that we can apply our multiplication concept, remembering that I said before that the logarithm of a in base of b can be written in 2 ways. We can write this as the logarithm of a everything over the logarithm of b. So we have got the logarithm of a, this part on the a, the number that is multiplying or that is affecting your log, and the base. So this is going to be over the logarithm of the base, which is b. So it's log a over log b. The same law that we are having is same as 1 over the logarithm of a. We interchange now, it will be b in the base of a. So interchange the base and the number. I explained this one in another way. I think this one is the one that we had before. So it is the same law that we are using from the same logarithm of a in base of b, which can be related in this way. So in this case, I'm going to relate this part and this part, since we want to convert it to a normal fraction, not just a complicated, but a normal fraction like a over b. So you have got log 2 in base of 3. So how can we write this log 2 in base of 3 as a number that is a fraction like this one? So you're just going to have log 2 over log 3, the base, the number and the base, the number and the base, like that. So this is going to be equal to the logarithm of 2 over the logarithm of 3. All right, multiplied 2, we move on. We've got 4 and 5. So this is going to be the logarithm of 4 over the logarithm of 5. We do the same thing, 5 and 8. This is going to be times the logarithm of 5 over the logarithm of 8. Multiplied to log 3.5. So this is going to be log 3 over the logarithm of a half in this case. So this is what you're going to have. Yes, we can cancel since the numerators are the same on the other part, but before you cancel, you can even simplify further numbers or logarithms such as log 4, which are not in simplest. We've got 2, we've got 3, 5 in simplest form, but 4, 8.5, these ones, we can rewrite them in simplest form. So 4 is same as the logarithm of 2 squared. So we can drop the exponent, multiply by the exponent. This is going to give us 2 logarithm of 2. All right, so meaning to say here, we can have this as the logarithm of 2 over the logarithm of 3 multiplied to the log of 4, which you said is 2 log 2. So this is going to be 2 log 2, everything over the logarithm of 5. We move on here, multiply to the logarithm of 5. It's in simplest form, but logarithm of 8 is not in simplest form. So 2 can be used in this place in place of 8, where 8 is same as 2 to the exponent of 3. Using the same concept, this is going to give us 3 logarithm of 2. We just drop the exponent to multiply the logarithm. So this is going to be 3 log 2. Multiplied to the logarithm of 3, it's in simplest form, but the logarithm of a half is not in simplest form. So how can we write the logarithm of a half in simplest form? Remember that a half is same as 2 to the exponent of -1. So if it is 2 to the exponent of -1, that means we've got the logarithm of 2 to the exponent of -1. So we can drop the exponents just like on 3. So this is going to be -1, the logarithm of 2. So meaning to say, the logarithm of a half can be written as the negative logarithm of 2 in this case. All right, so let us see what we have. Remember, from our fractions, as long the numerators and denominators are the same, we can cancel. So in this case, we've got log 2 and log 2. These two can cancel. Log 2 and negative log 2, meaning to say we're going to remain with negative 1. All right, we've got log 3 in the denominator, log 3 in the numerator. This can cancel. Log 5 in the numerator, log 5 in the denominator. This can cancel. So as you can see, we are left on the numerator on top here. We are just left with these two. It was not affected. So we are remaining with a 2 in this case. In the denominator, we are remaining here with a 3 and a negative 1. So if you multiply 3 times negative 1, you obtain a negative 3. So this is 2 over negative 3. But 2 over negative 3 can be written as negative 2 over 3, just writing the negative on top. Remember, just for simplification part, but our answer is supposed to be negative, is supposed to be 2 over negative 3, but we can simplify that in simplest form. All right, so that was just for 3 marks. All right, so let's check the other part, which is to solve for x. The other part of our question was to solve for x given the logarithm of 8x plus 2 log x minus 8, which is minus 3, which is equal to 0, and we're asked to solve for x. All right, what can we do here? All right, let us just have our log rewritten. Let me just rewrite our log. That's 2.21. 2.21, we're given the logarithm of 8x plus 2 the logarithm of x minus 3 is equal to 0. So actually, we do not know what type of an equation are we going to end up with, but all we need is to apply the laws. Wherever our laws is applicable. We were supposed to add our logarithms here, but we are supposed to actually apply the laws of addition. But we can't add because of the number 2 that is affecting the log. This is not a single log. Remember, for you to apply your laws, you're given that it must be a single log, the logarithm of A plus the logarithm of B. In this case, a single logarithm. We can multiply the numbers, that is A times B. But here we have got a number which is 2, which makes this not to be a single log. So what are you going to do? Get rid of that 2. Remember, from our laws, if a number is multiplying a log, we can raise that number to be the exponent of that logarithm. That's log m to the exponent of n. So we're going to raise these two to be the exponent to n. That means we have got the logarithm of 8x plus the logarithm, if we raise this, that will be x to the exponent of 2 minus 3, which is equal to 0. Now, if we check properly what we are given here, we've got a single log and a single log having the base of 10. If the base is not indicated, meaning to say we have got the base of 10. And I said, if we are adding our logarithms, we can multiply the terms that are under those logarithms that we are working with, meaning to say we can multiply the 8x and the x cubed because we are adding the logarithms here. So we're going to have the logarithm of 8x multiplied to x cubed, in this case, everything in base of 10 minus 3. This is not a log. This 3 is not a log. So this we are just going to subtract it, equate to 0. Okay, so that's we multiply 8 by x to the exponent of 3. That is going to give us x. This is 2, not a 3. I rushed here. This is still a 2. So I wonder, okay, someone might be wondering what's happened. This is a 2. That's 8x times x squared. So this is 8. Then now we can multiply 8x by x squared. That's here we can add the bases, since the exponents, since the bases are the same. That's 8x to the exponent of 3. So meaning to say here, if you combine this, we are going to obtain log 8x to the exponent of 3 like this in the base of 10. Then what about the negative 3? The negative 3 have got nothing to do with our logarithm, so we can transpose this to the right-hand side so that it can be a positive. It was a negative like this, so the right-hand side, it is going to be a positive. Why writing on the right-hand side? Because we can change this logarithm to an exponential equation. Remember, guys, I explained that the logarithm. All right, let me change this one to this. Okay, let me use this. The logarithm of a in base of b, if it is equal to c, remember I said this can also be written as a, which is our number affecting the log is equal to the base, which is b to the exponent of c. So this is b to the exponent of c. So what does it mean? We can change this into an exponential equation, which is easier for us to solve because this is representing your a, which we can write as our a, which is 8x to the exponent of 3 is equal to the base, our base, which is 10, raised to the answer as your exponent, which is 3. So that's 10 to the exponent of 3. So that's it, guys. 8x cubed is equal to 10 to the exponent of 3, which is 1,000. So we want to calculate the value of x. 8 is doing nothing. Can just divide by 8 since we are multiplying. So this we can remain with x to the exponent of 3, which is equivalent to 1,000 over 8. So how can we simplify 1,000 over 8 from there? We have the cube in this case, the opposite of the cube. That will be the cube root both sides. The number on your exponent is the one that you put inside the root sign. So this will be the cube root in this case, meaning to say we have neutralized to x. And the cube root of this, the cube root of 1,000 from your calculator, that's a 10 over the cube root of 8, which is 2, or you can just simplify that, or direct this one. That will be 10 over 2, and 10 over 2, which is simply a 5. So it means our x is simply a 5 in this case. All right. So like I said, this part you can just solve direct from your calculator, the cube root of this expression direct. Or here, also the other way that we could have worked from this part where we have got, okay, this part here where we've got x to the exponent of 3, which is equal to 1,000 over 8. Remember, to remove the exponent of 3, we can raise or we can multiply by a third, meaning to say we can raise everything on the right-hand side to the exponent of third. 3 times a third, that's a 1, meaning to say we remain with x being equal to this whole expression of 1,000 over 8 to the exponent of a third, which you can simplify from your calculator. Still, you are going to obtain your x as a 5. All right, so this is the value of x that we were supposed to have. It's a positive, and this actually makes sense because on this part, we cannot have our x as a negative. So this time, there's nothing that we are going to do. Our answer is fine like that. All right, then we move on to question 2.23, which is again to solve for x. But this time, this is not a log, it's a direct exponential that you're given, but check 7 marks for that. All right, so what is it that we can do to solve for x from this equation? If you are to not have got something that is happening, 1 over 4 to the exponent of minus x minus 2 to the exponent of 2x minus 1 plus 2 to the exponent of 2x plus 1, which is equivalent to 5 over 12. There is something here about the 2 to the exponent of x then. All right, so let us just work it stage by stage. 1 over 4, let us start with 1 over 4. We know that 1 over 4 can be written as 4 to the exponent of negative 1. But in the base of 2, because there's something that has to do with 2, so let us simplify this back to 2. So 4 in the base of 2 is same as 2 to the exponent of 2, but there is a negative 1 that we already have from 1 over 4. So that will be 2 times negative 1, which is negative 2. So we've got 1 over 4 here can be written as 2 to the exponent of negative 2. So meaning to say we are going to have 2 to the exponent of negative 2, but already there's an exponent that we already have here of a negative x. So the whole part that we have here is going to be raised to the exponent of a negative x. All right. Let us move on to the other stage. As we can see here, we have got another exponent, but another part, but this is a combination of expressions that we are given, 2x minus 1 on the exponent. So what you're simply going to apply is you separate this from which concept x to the exponent of a by x to the exponent of b gives us x to the exponent of a plus b. So what you're going to do is if you simplify 2 to the exponent of 2x by 2 to the exponent of negative 1, you are going to add 2x plus negative 1, and this will give us 2 to the exponent of 2x minus 1. So meaning the same way or the same 2x minus 1, which was under or which was affected by these 2, can be splitted as 2 to the exponent of 2x being multiplied to 2x to the exponent of negative 1. So this is same as 2 to the exponent of negative 1. Under multiplication, this is just one and the same thing, which is the same concept here. This time we are adding. So we're going to simply separate the same way that we did it, but now we are adding. So this is going to be plus 2 to the exponent of 2x multiplied to 2 to the exponent of a 1. And this whole part is equal to 5 over 13. 2. So 5 over 32, this is just a normal fraction, so we can just leave it like that. So here, this is what we could have done. From this part, we can expand this way. Why exactly having this separated? I want you to see what's going to happen from this stage. Negative 2 and negative x can be multiplied together, and this gives us a positive 2. So meaning to say we have got 2 to the exponent of 2x minus 2 to the exponent of 2x multiplied to 2 to the exponent of a 1 of a negative 1, of which 2 to the exponent of a negative 1 is same as 1 over 2. So you can even write this as 1 over 2, or you can just leave it like that. All right, so this is, or you can write it as 1 over 2 by 2 to the exponent of what? Of 2x. The same thing, 2 to the exponent of 1, it's a 2, so you can write as 2 times 2 to the exponent of 2x. So this is a multiplication, which is equal to 5 over 32. If you notice this here, you can see that there's something about this expression that is common throughout. On the left-hand side, 2 to the exponent of x is common, so meaning to say we can factor out or we can factorize. So here we are going to factor out 2 to the exponent of 2x. That is to factorize. If we factor out 2 to the exponent of 2x out of the bracket, what are we going to remain with? Because it's common. So this part and this part divides, that's a 1, minus these 2 and this cancel, we remain with a negative half. We do the same, this part and this part cancels, you remain with a plus 2. So this is what you're going to remain inside the bracket, being equal to 5 to the exponent of 32. This is a question that does not even limit us to the use of a calculator. It's just to solve for x, meaning to say the use of a calculator is allowed. So what you can do is to simplify this direct on your calculator, 1 minus a half plus a 2 direct on your calculator. This is going to give us 5 over 2. Thus, we've got 2 to the exponent of 2x times 5 over 2. Inside the bracket, we are obtaining 5 over 2, which is equal to 5 over 32. A bracket is the same as multiplication. So if you are given a bracket, simply means you are multiplying. So if we are multiplying, it means we can divide by that bracket of 5 over 2 both sides. We divide by the bracket of 5 over 2 both sides. Thus, we are going to remain with 2 to the exponent of 2x on the left-hand side. And from the right-hand side, we simplify this to this part, 5 over 32 on the calculator, 5 over 32 divided to 5 over 2. That is what I'm saying. This part is same as a single part like this. 5 over 32 divided to 5 over 2. You are going to obtain 1 over 16. So this will be 1 over 16. All right, so that's 1 over 16, which we can write in the base of 2 because we've got 2 to the exponent of 2x. Remember, if the bases are the same, I explained that if x to the exponent of a is equal to x to the exponent of b, it means automatically a is equal to b. So what does this part apply, or how are you going to apply this part? All right, this is what you're going to do. This is what you're going to do. You said a is equal to b here. I'm going to take this part. So we are going to rearrange or to write this 1 over 16 so that it can be written as 2 to the exponent of. So let us work it aside here. 1 over 16 is same as 16 to the exponent of negative 1 to remove this 1 over that we see. But to the base of 2, this 16 is the same as 2 to the exponent of 4. So that's 2 to the exponent of 4 times negative 1 that we see here, which is going to give us 2 to the exponent of a negative 4. So meaning to say wherever we are seeing 1 over 16, it is the same thing as 2 to the exponent of negative 4. So if it is the case, therefore, the bases here are the same. We've got 2 and 2. So what are we going to do? We are going to equate the exponents now. That's 2x and a 4. So here we are going to relate to say 2x is equivalent to negative 4. We have a linear equation that we are used to, where 2 is multiplying. We can divide by 2 both sides. So therefore, our x is going to be minus 4 divided by 2. That will be a negative 2. All right, so here we are going to obtain our x as a negative 2. All right, so this is the value of x that is going to normalize this equation. Remember, the value of x is the value of x, that makes the left-hand side to be equal to the right-hand side. So if we substitute this value of x, which is -2, on the left-hand side, wherever there's an x, we substitute with -2, our answer is going to give us 5/32, which is exactly what we have on the right-hand side. So I want you to substitute this value of x properly on your calculator and see if you're obtaining the exact value of 5/32 on the right-hand side. Okay, guys, that's what we had on this platform from Maison African Motives. Till we meet again.